So in grade 11, your first unit is real numbers. So real numbers means they are consist of two types of numbers. Real numbers consist of two types of numbers. One is rational numbers. Another one is irrational numbers. Irrational numbers. So how to define rational and irrational numbers? When a number that can be written as in the form of a over b. Let us take an example. 4 as an example. 4 over 1 is equal to 4. So when we write this number on a form of a over b, the a and b must have to be in the set of full numbers. Full numbers. So a and b must have to be in full numbers. They can be in decimal or they can be in square root. So like that we can define rational numbers. So the opposite of them, when we write the numbers in the format of a over b, when the a and b are not in the set of full numbers, this number is an irrational number. Irrational number. And rational plus irrational numbers are the parts of the real numbers. So this is the brief of this unit. Then in rational numbers, we can divide rational numbers into two parts. So we can divide rational numbers into two parts. First one is the finite decimal and the next one is the recurring decimals. Recurring decimals. So in finite decimals, you can see that the numbers will finish on a certain point when we are writing them on decimal format. So look at this one, 4.000. So the number is finishing here. 0.5 or half. 1 over 2 is equal to 0.5. This one finishes here on 0.5. So this is a finite number. This one is also 11 over 8 is equal to 1.37500. So the number finishes here. So we could call these numbers as finite decimals. Finite decimals. Look at these cases. This number is a rational number, but this is a recurring decimal. This is not a finite decimal. So 211 over 99. So that one is 2.13131313 continues. So the 13 is repeating. That's because we call them as recurring numbers. In here also 5.113333 continues. So we write the number shorten 5.113 dot dot dot. Here we short the number like 2.13 dot 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 13 dot dot. Here in this case also 37 over 7 is a rational number, but this is a recurring decimal. It's repeating again and again. The decimal number is repeating again and again. So when we consider these numbers, these are the recurring decimals and these are the methods how to write the numbers concisely. Okay, so 12.4 writes like 12.4, 444 writes 12.4, finishes here. 2.131313 2.13. So the 13 repeats here, 4 repeats here. Here 5.113. So the 3 repeats here. Here 5.25714. So the 5.285714. So the 285714 repeats here. So these are the basics of the these are the basic you have to know to do the exercise number 1. So for each of the following rational numbers, state whether it's a finite decimal. So these all are the rational numbers. We know that when we write the number on a fraction format, the upper portion and the lower portion, it means the numerator and the denominator has to be full numbers, so they will be rational numbers. But he's asking that is that a finite decimal or recurring decimal. So here is a hint. Here is a hint to find the finite decimal. Oh, is that the recurring decimal? You have to check that. You have to check that. The you have to check. You have to check that is that the denominator is the lower part of the fraction is it in the power of 2 or power of 5? Is that on the power of 2 or 5? It will be a finite decimal. Is it not? Is it not? It will be a recurring decimal. Example, look at the first example, 3 over 4. So the denominator is what? 4. So 4 is a 2's power, right? 2 to the power 2 is 4. So this will be a finite decimal. This number, this rational number will be a finite decimal. Here also, look at here. 5 over 5. So the denominator is 5. So this is a power of 5. 5 into the power 1. 5 to the power 1. So this one also a rational number. This one also a rational number. So first one is a rational number because the denominator is a 2's power and here 5's power. In here the 7 is not a number 2's power or number 5's power. So it will be a what? It will be a recurring decimal. So this is not a finite decimal. So same like that, this is not a finite decimal. This is also not a finite decimal. This is a finite decimal. Here, this is not a finite decimal. This is not the power of 2 or power of 5. This, in this case, 13 over 50, we can write 13 over 5 into 10, right? 5 into 10. 13 over 5 to the power 2 into 2 to the power 1. It means you can write 10 as 5 into 2. So we can show this one 5 to the power 2 into 2 to the power 1. So these are in 5's powers and 2's power. So this will be a finite decimal. Here 64 is equal to 2 to the power 6. So this one will be also a finite decimal. This one is not n finite decimal. This one is a finite decimal and this one is not n finite decimal. So these are the things he is asking on the first question. And next question express the fractions which are recurring decimals in decimal form and then write them in a concise form. So you can divide them by using calculators and you can concise them by the method we have studied on the last page. Right here is the concising method. Here is the concise. How to write the recurring decimal on concisely. Right. So you can refer this chart and you can do the balanced questions. So we will meet with the activity number 1.2.